This question is given in GATE 2008. Okay, in the following limited circuit, an input voltage VA equal to 10 sin 100 pi t applied. Assume that the diode drop is 0.7 volts when it is forward biased. The Zener breakdown voltage is 6.8. They have given the circuit. This is the circuit given with two lines of diodes. One is Zener diode indicated by Z. Another one is normal diode. The maximum and minimum values of the output voltages are respectively are. Okay, they are asking what is the maximum and minimum output voltages whenever we apply input 10 sin 100 pi t. Okay, now generally while coming to the concept of diodes, whenever positive is applied to P side, it will be in forward bias, else reverse bias. This is the concept of diode, important concept. When we can say diode is forward bias is whenever positive voltage is applied to P side, then it is forward bias, else it is in reverse bias. Okay, this you should keep in mind. By using this concept and the concept of Zener diode, we are solving the problem. Now we will go for Zener diode. Zener diode. I will draw the diagram of Zener characteristics. Okay, this is how it will look like. It will maintain some constant voltage, and after some point it will be like this. Okay, just sorry if I am not drawing properly, but this will be 0.7 volts. Okay, now, and it maintains a constant voltage up to here. This point is called Zener breakdown voltage, VZ indicated by. Okay, now this is said to be in on state, this is said to be in off state. Okay, now coming to here, whenever this Zener diode applied voltage V is greater than this Zener breakdown region, it will be maintaining some constant voltage. Okay, or whenever applied voltage V is less than Zener breakdown region voltage, it will be in reverse bias. Okay, this you should keep in mind. Here this will be in forward bias. Whenever V greater than 0.7, it will be in forward bias. This is the simple three things which you need to remember regarding Zener diode. Whenever applied voltage is greater than 0.7, it will be like in forward bias, on state. Whenever this applied voltage is greater than Zener diode, it will maintain a constant voltage. Whenever this Zener diode applied voltage is less than Zener breakdown region, it will be in reverse bias. Now while solving this question, given signal VI equal to 10 sin 100 pi t. So this here we need to consider two cases where VI equal to plus 10 volts is one case, another case is VI equal to minus 10 volts. Now I will redraw the same circuit whenever we are applying positive voltage and whenever we are applying negative voltage. Okay, here this is the circuit I am redrawing. This is the resistor. Now assume that here plus 10 volts is applied. Plus 10 volts is applied to the P side. So diode will be in forward bias. Okay, and Zener diode will have maintain a constant breakdown voltage. This will be in forward bias, maintains a 0.7 volts as given in the question. And here if you observe, plus 10 volts is applied to N side, so this will be acting as a open circuit. Okay, it will be in reverse bias, acting as open circuit. Now we need to calculate V0 equal to how much. Okay, now we can calculate V0 by simply adding these two. Okay, 0.7 plus 6.8, that is equals to plus 7.5 volts. V0 is equal to plus 7.5 volts whenever we are applying VA equal to plus 10 volts. Now we will redraw for whenever Vi equal to minus 10 volts. Whenever we are applying minus 10 volts, we are redrawing the circuit. See here resistance will be there. Minus 10 volts we are applying. See here minus 10 volts we are applying, and here minus 10 volts is applying to the P side. So this will be act as reverse bias open circuit. It will be in reverse bias, so it will act as open circuit, and minus is connected to Zener diode. So this will be in forward bias. So maintains a constant like 0.7 volts. This one, right? 0.7 volts, and this circuit will be like this diode will be minus is applied to N side. So this will be in forward bias. Like this it will be. This will be V0. Now this will having 0.7 volts. Minus plus. This is how it looks like. Now we can calculate V0 by, it will be straight away you can tell, because this is an open circuit, we cannot consider this. So straight away we can get it will be minus 0.7 volts. So this is how we can calculate. This will be the max and this will be the minimum. Because max we will get whenever we are applying positive voltage, min we will get whenever we are applying negative voltage. This is how we can solve the question, and the answer is plus 7.5 volts minus 0.7 volts. Where is that plus 7.5 and minus 0.7? Option C is the correct answer. How we have solved out this question is, first we should know the basic concept of the diode. Okay, whenever positive voltage is applied to P side, then we can say diode is said to be in forward bias. Okay, or whenever otherwise it will be in reverse bias. Whenever it is in reverse bias, it acts as open circuit. Whenever the diode is in reverse bias, it will act as open circuit. Now coming to the Zener characteristics. There are three cases here. First case is it will be in forward bias on state. It will maintain a voltage of 0.7 volts. Okay, and the second case is categorized into two categories. This is the second one, this is the third one. Here whenever applied voltage is greater than Zener breakdown voltage, it maintains a constant voltage. Otherwise whenever applied voltage is less than Zener breakdown voltage, it will be in reverse bias condition. Whenever any diode is reverse bias condition, okay, it will act as open circuit. Okay, this is how we can solve this question.